Hello everyone, this video is going to cover Workbook Exercise 7a, question 4, 5 and 6, which is on Chapter 7.2. We will first take a look at question 4a, where we want to simplify these two fractions, okay, that are multiplying with each other. So to multiply these two fractions, we will multiply the numerator together first and also multiply the denominator together. As such, we will get 8a squared bc over 8a squared bc squared. Then we will have to simplify the the answer, such that we will cancel away the 8. Okay, and then after that we will also cancel away a squared because it occurs in both the numerator and denominator. Whereas for the b, we'll also cancel that because there is there's b in both the numerator and denominator. And finally for c, okay, we have c in the top and c squared at the bottom, so we will only be able to cancel away 1c. Therefore our answer will be 1 over c. The fact that there is nothing at the top does not mean that it is 0, okay? It is actually being divided accordingly such that they are all equals to 1. So 1 times 1 times 1 times 1 will actually be just 1. Therefore, the answer will be 1 over c. I hope you got this answer. Next, we want to simplify the question in part B, where we are given two fractions that are dividing by each other. So when it comes to division, we will have to flip the fraction on the right, and then after that multiply them together. So we multiply the numerator and also multiply the denominator together. Then we will get this fraction over here. Upon arriving at this fraction, we will do our usual cancellation of common factors. Hence, between 210 and 60, we can simplify it to have 7 over 2, because we can divide by 30 in both numerator and denominator. Then for x cubed and x, we can only divide away 1x, so we will get x squared in the numerator. Then, having only y cubed at the numerator, we do not have any y at the bottom, so we keep the y cubed. Lastly, for z squared and z to the power of 5, we can cancel away the z squared, hence we are left with z cubed in the denominator. Therefore, our answer will be 7x squared y cubed over 2z cubed. I hope you are able to get this answer as well. Now in part C, we are also given two fractions that are dividing by each other. So we will first flip the fraction on the right to arrive at multiplying 6p plus 6q over 8 on the right side. Okay, before we go into multiplying the numerator and the denominator, we will want to actually factorize the numerator and the numerators first, because we observe that in the numerators, they can both be factorized. So the first one, 2p plus 4, when we factorize, we take out the 2 and we bracket p plus 2. For 6p plus 6q, we also take out the 6, which then multiply by p plus q. Okay, I have a reason for doing this. Alright, let me please hold on to that first. Then we will now proceed on to multiplying the numerators. So 2 times 6 will give me 12. P plus 2 times p plus q will have these multiplications here. In the denominator, there's nothing for us to factorize, so we get 8 times p plus q. Okay, so because we have done the factorization, then now we can clearly see that we can cancel away the p plus q because they are in common at both top and bottom. Hence, we get the answer to be 3 times p plus 2 over 2, because 12 and 8 can also be simplified to give us 3 over 2. The reason why we did not choose to actually directly multiply at the top, the reason is because if we had done 2p plus 4 times 6p plus 6q over 8 times p plus q, it will not be obvious to us, okay, in terms of the cancellation. Alright, so we should factorize as far as possible first before we do any multiplication. In question 4 part D, we are given two algebraic fractions that are multiplying by each other. Okay, so as per usual, we would want to think about multiplying the numerators together first and also the denominators together. But that will complicate things very much for us. So what we should choose to do is, whenever we have fractions, we try to factorize, okay, whenever possible first. And we see that 2x minus 6 can be factorized such that we get 2 times x minus 3. Similarly, our 8xy minus 24y can be factorized to give us 8y times x minus 3. And finally, 5x plus 5y can also be factorized to give us 5 times x plus y. So we always try to factorize first. Then we will actually go on to multiplying the numerator and denominators. So 2 times 7 will give us 14, x minus 3, then after that multiply with y plus x. In the denominator, the same things apply. So 5 times 8 give me 40y times x plus y times x minus 3. Then we can do our respective cancellation. X plus y is actually the same thing as y plus x, so we can cancel them out. X minus 3 can also be cancelled out. Don't forget the numbers, so between 14 and 40, both can be divided by 2, so we will get 7 over 20. Therefore, our answer will be 7 over 20y. I hope you are able to understand this answer. So we will now take a look at question 5a, where we want to simplify the multiplication of these two algebraic fractions. So just like before, we will want to actually factorize wherever possible first. And we see that 2x minus 8 can be factorized to give us 2 times x minus 4. Then in the denominator, we can also factorize to get 7y times x plus 5. And finally, in the second fraction, numerator itself, we can also factorize to get 3x squared times x plus 5. Then we proceed with multiplying the numerator and denominators respectively. Hence, we get 6x squared, because 2 times 3x squared will give us 6x squared, times x minus 4 times x plus 5. And in the denominator, take note that this x minus 4 is actually together, so therefore we have these brackets over here. Alright, we do not need to do any rainbow method or expansion, because eventually we want to do some form of cancellation. So we will want to cancel away x minus 4, okay, and also x plus 5. Now between 6x squared and 7y, there is nothing in common actually, so therefore our answer will be 6x squared over 7y. Earlier on in the previous question, when we talked about factorizing the numerators or denominators, we were doing extracting by common factors. But now in part B, we see that we have a squared minus b squared, which I hope you find it familiar. It is what we have to do with, it is what we did using our special identities. So a squared minus b squared can be factorized, which is a plus b times a minus b. The rest of the fractions, or rather the rest of the parts in the fractions, can no longer be factorized. So we only factorize a squared minus b squared. Then we proceed to multiplying the numerators and also multiplying the denominators. So we get this fraction over here. Then we proceed into cancelling common terms. So we find that a plus b can be cancelled, okay, and a minus b can also be cancelled. Hence, we are only left with a plus b at the top. Hence, our answer is a plus b. We should not be writing a plus b over 1. Just like when I talk about the whole number 5, I do not write it as 5 over 1. Therefore, we simplify our writing as just writing the answer as a plus b. In question 5 part C, we have to simplify these two algebraic fractions that are dividing by each other. So whenever we have to do with division, we always flip them first. So we flip the fraction on the right only, and we get 10x minus 15y over x squared plus xy minus 12y squared. Then we go into factorization. So in the skill of factorization, okay, the numerator can actually be factorized for the left fraction, and we get this. And then after that, 10x minus 15y can also be factorized such that I have 5 times 2x minus 3y. Okay, then finally, when we talk about x squared plus xy minus 12y squared, that can also be factorized to give me x plus 4y times x minus 3y. Let me explain to you how this cross method actually worked, in case you don't remember it. So we have x squared minus 12y plus xy filled in this frame here. X times x will give us x squared. For 12y squared, we can consider 3y and 4y. Okay, if you considered something else, you will not be getting the answer, but therefore we need to do some trial and error. Okay, so 3y and 4y, then we do our cross and we will get 3xy and 4xy filled over here. Because the question wants it to eventually be a positive xy, where at this section we are only doing addition, so in order for 3xy and 4xy to add together to become a plus xy, this must be a plus and this must be a minus, because plus 4 minus 3 or minus 3 plus 4, they will give me a plus 1. Okay, so now that we have put in the minus and plus sign here, it must be brought over here as well. And this is consistent with the fact that when I multiply in this area, multiplying a negative and a positive will give me a negative. That is how I get the factorization of x minus 3y times x plus 4y for that expression. Then we proceed into multiplying the numerators together and the denominators together. Okay, taking note that 2x minus 3y here is together, that's why I put brackets over here. Following from there, I will cancel the common factors between the numerator and denominator, so I can cancel away 2x minus 3y, and I also can cancel away x minus 3y. Finally, our answer will be 5x over x plus 4y. Moving on to question 5D, we would like to also divide these two algebraic fractions. So what we need to first do is to flip the fraction on the right to get this over here. We also need to observe that the parts 9c squared minus 6cd plus d squared can be factorized, as well as 3c squared plus 5cd minus 2d squared. So for 9c squared minus 6cd plus d squared, the factorization that we will be doing is via cross method. So we get 3c minus d squared. Let me show you how that is done. So 9c squared, we will think of having 3c times 3c. Then after that, for this plus d squared over here, we would only think about d times d. So when we cross it, we will have 3cd here and 3cd over here. In order to have a minus sign over here, or in fact a minus 6, we can only do so if this is a negative 3cd and a negative 3cd, such that this area, when it adds up, negative 3c plus negative 3c, we will get negative 6cd. Sorry, I meant negative 3cd plus negative 3cd will give me negative 6cd. So with these minus signs here, I will consider minus signs over here. And if we're looking at multiplying in this area, minus times minus will give me plus. Therefore, I have 3c minus d times 3c minus d. And that is actually considered as saying 3c minus d bracket square. That is how I got this factorization over here. So this is for the numerator on the left fraction. Now, for the denominator of the right fraction, which is 3c squared plus 5cd minus 2d squared, when I factorize it using cross method, I will get this answer. So, same thing, 3c squared, we may consider 3c times c. Then after that, for 2d squared, I may consider 2d and d. If I do this and I cross multiply it, I will get 2cd and 3cd over here. However, in order to have 2 and 3 to give me positive 5, it will mean that this is a plus and this is a plus, which means that this is a plus and this is a plus. But we know that plus and plus doesn't give me minus. So there is something not right going on here. So we need to consider changing the things that we have here, okay, such that we get 2d squared. So earlier on, we start with 2d and then with d. Let me do the change here. So what if we flip it over to the other side? Do I have d and 2d instead? Okay, then upon cross multiplying it, we will get cd over here and 6cd. In order to have a plus 5cd, that would mean that this has to be a plus 6cd and minus away cd, because we are looking at adding up over here. Alright, so since we have decided on a minus and plus here, we will have minus and plus, and this is consistent with the fact that minus times plus will give me a minus. So that is how I get 3c minus d times c plus 2d, factorization in this case. Now that we have completed the factorization, we can multiply the numerators together and also the denominators together. Take note that I have combined 3c minus d with this 3c minus d to write it as 3c minus d bracket square when I multiply. Then I can now cancel away 3c minus d square in both the numerator and denominator. Therefore, I have the answer d over c plus 2d. We will now take a look at question 6, which is a problem sum that we are required to solve. It says that Michael earns a fixed salary every month. Last month, the ratio of the amount of money he saved to the amount of money he spent is 5:9. So we are talking about amount of money he saved, okay, and then after that, the amount of money he spent, right? That is, the ratio will be 5:9. Then following from there, this month itself, he decides to save $720 more. So he saved this amount more, okay, and then the ratio actually becomes 13:15. So it is in the same ratio as in the same format of ratio just earlier on. So 13 is for amount saved and 15 is the amount spent. So the question actually wants us to find out how much does he earn every month. Alright, to actually do this question, we will start off with defining certain stuff first. So what we will do is to let the amount of money saved last month be actually $5x. And then the amount of money spent last month will be $9x. So this is all talking about last month. How I get this 5x and 9x, okay, is actually based on the ratio that I have over here. Alright, then after that, because it says that he decides to save $720 more, that means that in this month itself, okay, originally he had $5x, now he has $720 more, so we add another 720. So where did this 720 came from? It came from the amount that he spent last month. Okay, so that means that last month he actually spent $9x. So this month it will be 9x minus away 720. Okay, so I hope that you see this part is for this month. This part is for last month, right? And this part over here is for this month. Okay, a good presentation will be whatever that I've written in blue. Alright, so now that we have already put this out, okay, and the only information that we have not yet used is this ratio 13:15. Since we already know how much he has been saving and spending for this particular month, that would mean that the ratio of 5x plus 720 and also 9x minus 720 needs to be the same as 13:15. So because they are going to be the same, we say that they are going to be equal. Okay, and that is how I get this particular equation over here. Alright, so now that I have gotten this equation, what we need to do is to cross multiply. Okay, and hence we have 15 times 5x plus 720 equals to 13 times 9x minus 720. Then we do the distribution law, or else we also call that the rainbow method, right, to actually expand this, and we get 75x plus 10,800 equals to 117x minus 9,360. Then it will just be a simple transformation or simplification of your equation. So we move things around. So I've decided to move the 117x over to the left and this 10,800 over to the right. Hence, I got this equation. Then I simplify and I get negative 42x equals to negative 20,160. Then I will be dividing, okay, negative 42 over to the right hand side. So therefore, x is equals to 480. But I want us to all take note, okay, that the question is not asking for value of x. Right, this is a very common mistake that you just stop your answer over here, okay. So let us go back to what the question wants. The question actually wants us to find out how much he earns every month. So the amount of money he earns every month would actually be the amount that he saves plus the amount that he spends in 1 month. Okay, so we can either make use of 5x plus 9x, or I can also do 5x plus 720 plus 9x minus 720. So either last month or else this month. Okay, obviously last month might be easier for us to calculate as compared to this month. Okay, so what I have decided to do is to make use of 5x plus 9x to determine what is the amount earned every month. Okay, every month he earns the same amount. Alright, so it doesn't quite matter whether you use the last month's combination or the this month's combination. Alright, then now I replace the x with 480 because that is what I have found over here. Okay, then after that I press my calculator and I get my answer to be $6,720. Alright, I hope you are able to get this answer. Okay.